So Mistral has dropped their brand new Mistral 3 model lineup, and this really has been a long time coming. If we go ahead and take a look at Mistral's blog, we'll see that the last product they released was Codestrol 2508, which was dropped all the way back in late July. And this is particularly relevant because Mistral has been one of the symbols of the AI movement in the European Union and also a champion of open source since their first releases back in 2023. So their drop on Tuesday includes two distinct lines. The first one is Mistral Large 3, which is their flagship mixture of experts model, just like everyone else has been doing, like Kimi K2, like GLM 4.6, or Qwen 3 Max. We've also got Ministral 3, which is a suite of small dense models that are designed to run on edge devices. Crucially, they have released all four of these models as open weights on Hugging Face under the Apache 2 license, with base models and instruct tune models and reasoning models. And it's good to see Mistral recommitting to the Apache 2 license, which is significantly more permissive than some of the licenses they have used in the past. So first, let's take a look at Mistral Large 3. Mistral Large 3 is Mistral's new large mixture of experts model, and it's multimodal, which means it can take in text and images and output text. If we dig into the configuration files on VLM, we actually see that the architecture is based largely on the DeepSeek V3 architecture, which throughout the past year we've seen has been pretty excellent. And not only DeepSeek, but also companies like Moonshot have been using that for their Kimi models. In fact, the parameter count for Mistral Large 3 is also pretty similar to DeepSeek V3, coming in at 675 billion parameters with 41 billion active parameters. Mistral here has made a slight change by adding a vision adapter to make the model vision capable, unlike these other Chinese models like DeepSeek V3 or Kimi K2. Comparing this to the DeepSeek V3 based model, in terms of compute, DeepSeek was trained on roughly 2000 NVIDIA H800s, which is an export control compliant chip with capped GPU to GPU interconnect bandwidth. Here, however, Mixtral uses 3000 H200s, which have higher memory bandwidth and uncapped interconnects. So as a result, we're looking at roughly 50% more compute in this cluster used for Mistral largely compared to the original DeepSeek V3 base run. So the ceiling of capabilities for the Mistral Large 3 base model is likely higher than that of DeepSeek V3. Sadly, Mistral has not disclosed what data they've trained on. My guess is that they're training between 15 and 20 trillion tokens, much like other of the open labs have been doing. In the past, however, Mistral has had significant reluctance training on synthetic data, as seen with their Mistral Small 3.1 model, and we don't know if this has changed here. Okay, now let's talk about the evaluations. We see that on the release blog post, Mistral has provided a number of benchmarks for comparison, and they're mainly comparing against these Chinese open models like DeepSeek V3.1 and Kimi K2. And it seems to me that Mistral understands that in the enterprise, what they're competing against for deployment is very much these Chinese models. On standard benchmarks like the MLU or reasoning benchmarks like the GPQA Diamond, it looks like Mistral Large compares pretty favorably to other non-reasoning last-gen models like DeepSeek V3.1 and Kimi K2. And if we go down here, we see that Mistral has done a number of these human preference evaluations. For general prompts, we see that they have a slight edge against DeepSeek 3.1 and Kimi K2, and for multilingual prompts, they have a commanding edge over these two models. Now, they haven't disclosed what languages are being assessed here in the multilingual prompts, but my guess is that they're containing some Eastern European languages that haven't been featured as heavily in Chinese model training sets. It would be interesting to see how they compare against Qwen 3 here, because Qwen 3 is the only Chinese model that's really known to have been trained on a whole bunch of different languages. I believe it's 119 around the world, so that is a bit of a shame. One overarching theme that we're seeing here is that Mistral seems focused on a different set of benchmarks than many of the other labs out there. Many of the frontier labs like Anthropic, OpenAI, DeepSeek, or ZAI have spent the last 6 months really optimizing their models for complex code, math, and agentic use cases. whereas Mistral's benchmark look more last gen, like the O1 models, where the models have been evaluated for skills rather than these end-to-end workflows. So before we incorporate Mistral Large 3 into our agentic systems, it will actually make a lot of sense for us to wait for some third-party evaluations on agentic benchmarks before we go ahead and do that. Now, other than the official benchmarks they've posted on the blog post here, I also ran some of my own evaluations to test deeper capabilities. Now, in particular, I was rather interested in Mistral Large 3's vision capabilities, since this is a key area where Mistral is differentiating itself from many of the Chinese models, which so far have largely been text only. For general knowledge, Mistral Large 3 seems to work pretty well. I also tested the model on these image visual question answering questions and these OCR benchmarks, and it seems like the model performs pretty well. That being said, these benchmarks are pretty standard at this point. I also ran Mistral Large 3 through my SVG generation benchmark, where models are given a prompt and asked to generate a corresponding SVG, which is then checked against a set of requirements by an LLM judge. So here, Mistral Large 3 scored 46%. This result seems to line up with the previous results, where Mistral Large 3 was compared against DeepSeek V3.1 and Kimi K2, where it performs around or beats those models in this benchmark. Slightly concerning, however, is that Mistral lost to their own previous dense medium model, Mistral Medium 3.1. And even more concerning is that the comparison to Qwen 3 Next ADB A3B Instruct, where the Qwen model, despite having less than 1/8 of total parameters and less than 1/13 the active parameters, Mistral Large 3 still lost here. That being said, regarding these specific coding and SVG results, according to a recent post on X from Mistral, we're probably expecting a new Codestral model soon, which might address these certain shortcomings. I also ran Mistral Large 3 through Gatebench, which is one of my benchmarks that tests visual reasoning and tracing by asking the model to trace logic gates in an image. Now, in this benchmark, it unfortunately scored the first ever 0%. For context, Gemini 3 Pro, the leading model at this point, scores 53%, and Qwen 3 VL 30B A3B Instruct, a way smaller model, was able to score 15.6%. So, although Mistral Large 3 seems to perform reasonably on general visual question answering capabilities, it does not seem to be able to do these reasoning tasks very well. The significance of the 0% score is that if Mistral attempts to apply reinforcement learning to this model and create a reasoning version, let's call it Magistral Large 3, it'll probably likely struggle as well, because RL works best when the target distribution isn't too far from the initial distribution of the model. So with a starting score of 0, it's hard to imagine the RL process successfully drawing out these visual reasoning capabilities out of this base model. Taking a look at the deployments here for Mistral Large 3, it's very clear that Mistral knows their model is competing against models like DeepSeek and Kimi for deployment in the enterprise. And Mistral has done something pretty smart here, where by releasing their models in the NVFP4 format, they're shrinking the model to 1/4 the original size and allows for fast decode because it saves memory bandwidth. And this is a place where Mistral has a significant advantage over the Chinese labs because they have access to Blackwell GPUs and are able to optimize for NVFP4. And as a result, they're able to deliver models with more efficient inference for enterprises which are planning to host internal agents on these current or next gen NVIDIA clusters. Now let's take a look at the pricing of this model. So if we look over here on Open Router, where many people are likely to be using these models, we see that Mistral Large 3 costs 50 cents per million input tokens and $1.50 per million output tokens, where the pricing really kind of sits between the Kimi K2 model and the DeepSeek V3.1 model. However, with DeepSeek V3.2, there has been another 70% decrease in the price for DeepSeek. So whether Mistral can remain competitive here is a question. Now let's move on to the Ministral 3 models, which are perhaps more interesting for the research community and people wanting to run these models on device. Looking at the blog post here, we can see that Ministral 3 has been released in 3 different sizes: 3B, 8B, and 14B, with base, instruct, and reasoning variants for each of these sizes. The 14B is likely being aimed with quantization to run on GPUs with 12 to 16 gigabytes of VRAM, the 8B for 8 gigabyte GPUs, and the 3B for edge devices like your phone or eventually your toaster. In many ways, it looks like Mistral seems to be gunning for the position of Western Qwen, where there are a large variety of models released to cover all sorts of different device classes and for research. And in my view, Ministral 3 is very much a strategic release trying to address a specific void in the open source ecosystem, where since the release of Llama 3.1 and 3.2, we really haven't seen many high quality, small base models from Western labs. And as a result, we can see that the Western research community have either been trying to squeeze all the value out of the llama models or have been relying almost completely on Qwen for experimentation and fine tuning. If we go to Hugging Face and look at the pages for a lot of these research firms, we can see that News Research Hermes 4 models have been built on top of Llama 3, where some of the models have been released in May of last year, up to 1.5 years ago. And looking at NVIDIA's Hugging Face models, we can see that they have largely moved away from Llama 3 to Qwen 3 for these past few months. And the same goes for Microsoft Research, etc., where some of their recent agent models have been built on top of Qwen 2.5 VL. At this point, Qwen has very much become the open standard, particularly because they offer so many different sizes for their models. Looking at the Qwen 3 series, we can see they offer up to 9 different model configurations, making their models ripe for experimentation with wildly different hardware setups. With this release, then, Mistral is effectively trying to become a Western Qwen by releasing models for locally running and for research in many different sizes, all with open base models, while being frontier for their size classes. Now, Mistral certainly isn't the only one trying to fill this gap. Recently, we've seen AI2 release Almost 3 in 7B and 32B variants, and Archie AI released the Trinity Nano and Mini models. That being said, I think Ministral 3 has a pretty good advantage here. Unlike the Archie release, which have been MOE models, Ministral is traditional dense, and this matters because the open source software ecosystem for fine tuning dense models is much more mature than that for a mixture of experts. So, by releasing high performing dense weights, Mistral is giving the research community a highly compatible base to work with. And compared to the Almost 3 dense models, the Ministral 3 models have significantly better performance and also offer more size variance. Mistral hasn't provided much details on how Ministral 3 was trained, but looking at the documentation here, where interestingly enough, we likely only have access to because it's legal documentation mandated by EU regulations, Ministral 3 was created by pruning the Mistral Small 3.1 24B model, which at this point is around 9 months old. And personally, I find it very interesting how many of these labs are now training small models. Many of these labs, like Llama and Qwen, are using on-policy distillation. For example, we know that for Qwen 3, this post-training for a lot of the small models was done via on-policy distillation from their larger flagship dense models, like the 32B and the 235B MOE model. Pruning, where weights are removed from a pre-trained model, is also pretty popular now. We've seen Cerebras do this recently with Kimi and the GLM models for deployment on their chips. So it's interesting to see how Mistral has used pruning here as their method of choice for training these small models efficiently. If we come down here and look at the first-party official benchmarks, we can see that Ministral 8B and 3B are achieving state-of-the-art or near state-of-the-art results, beating or matching similarly sized Qwen 3 models. That being said, looking at the timeline, these Qwen 3 models, or at least the base models, were released 7 months ago, so while Mistral is filling in the gaps, they are effectively catching up to where Qwen was half a year ago. In particular, the 14B comparison has a little bit of nuance to it, because although Ministral 14B is able to tie or beat Qwen 3 14B on almost all these benchmarks, the Qwen 3 14B model is significantly older and hasn't received the recent post-training updates that the Qwen 3 4B and 8B instruct models have received 2 months ago. So it's an easy win for Mistral, but not necessarily a fair fight. That being said, Ministral 3B, 8B, and 14B have no Western parallel, so in that field, they're doing very well. Here we can see how Mistral is highlighting the token efficiency of Ministral 3 compared to other of these instruction tune models like Qwen 3 8B. And this is particularly important because on these edge devices where Ministral is likely to be deployed, the compute is relatively scarce, and as a result, for these long sequences, as the attention grows quadratically, it becomes very compute intensive for these models to predict out the tokens. So if these models are able to achieve comparable results while having to predict out less tokens, it's much more advantageous for deployment on edge devices. I've also done some of my own tests, and in general, I have found the Ministral models to be very comparable, or in some cases, beating the Qwen 3 models in a lot of these use cases that you would want locally. Things like summarization, translation, etc. That being said, although the instruct variant of Ministral 3 seems to be quite a bit more concise than the Qwen 3 models, the reasoning variant is every bit just as verbose, and in many cases I see them predict down longer chains of thought than the Qwen 3 reasoning models. If we take a look at a particular chain of thought here, we can see that the model generated over 160 weights just to doubt itself and loop through refutations. It works, but it lacks the efficiency of the mature chain of thought that we're now seeing from many of these labs, and in particular from OpenAI's GPT OSS models, where they're able to achieve good results with a very short chain of thought. So while the instruction-tuned Ministral 3 models are likely more token efficient than Qwen 3 Instruct, the reasoning variants are still very verbose thinkers. This behavior here is actually very similar to some of the earlier Chinese reasoning models we saw, like QWQ32B or DeepSeek R1, so my guess is that Ministral 3 likely used chain of thought examples from these models as cold start data before the RLVR phase, leading to a similar style in outputs. Now, one of the things I've noticed about the Ministral 3 models is that compared to Qwen 3, they are significantly less performant at tool calling. We can see in this example here that even when Ministral 3 8B reasoning is given these web search and website reading tools, it just doesn't use these tools by default. And when I tell it to do so explicitly via the prompt, it goes ahead and hallucinates results for these tools. I've checked the chat template and it seems to be correct, so I'm not entirely sure what's going wrong here. My rough guess is that Mistral 3.1, which these models were pruned from, used very little synthetic data for training, which likely means there weren't a lot of tool use examples, which nowadays are largely being generated via synthetic data. As a result, these pruned models from Mistral Small 3.1, like Ministral 3, haven't been very performing at tool calling either. So overall, I think Mistral 3 is a pretty solid release. It really shows that Mistral is still in the game and pushing forward for research and local uses with Ministral 3, trying to fill the role of a Western Qwen. That being said, a gap still exists with the current gen Chinese open weight models and also with the frontier Western labs like OpenAI, like Anthropic, or Google. So tell me what you think about Mistral 3 in the comments below, whether you're going to use it for deployment, etc. I'll see you in the next video. Bye for now.